Greetings, everybody. So in this problem, we're asked to find the distance traveled by a particle with position x, y, as t varies in the time interval between 0 and 3 pi, where x is going to be given by sine squared and y is going to be given by cosine squared. Well, if we look at our arc length differential form, what we find is that it will be given by the square of dx dt plus the square of dy dt, the square root of the sum dt. And so what we need in this particular case is the derivatives of each one of our functions x and y. So if x is going to be given by sine squared of t, then we have for dx dt is 2 sine of t cosine of t. Likewise, for y being cosine squared, we're going to have dy dt equal to a negative 2 cosine of t sine of t. So plugging this into our differential form, what we find then is the ds is going to be the square root of a 2 sine of t cosine of t squared plus a negative 2 cosine t sine of t squared, and then outside dt. So when we simplify this, what we find is we have a 4 sine squared cosine squared plus a 4 cosine squared sine squared. So we end up with the square root of 8 sine squared t cosine squared t dt. Or if we take the square root of that, what we have is 2 root t times the absolute value of the sine of t times the cosine of t dt. Now we're ready to take these values and plug them in to our arc length function. So for the arc length s, that's just going to be the integral over our curve of ds. And so in our case, this gives us the integral from 0 up to 3 pi of 2 root 2 times the absolute value of cosine of t times sine of t dt. So using one of our double angle identities, we can take that 2 inside the absolute value. And so what we have then is the square root of 2 times the absolute value of 2 cosine t sine t being actually the absolute value, so 0 to 3 pi, of the square root of 2 times the absolute value of the sine of 2t dt. So now, because our sine of 2t is going to, in some intervals, be positive and some intervals be negative, when we do the absolute value, we need to take into account where it's going to be positive and where it's going to be negative. So if we sketch the graph of the sine of 2t, what we're going to find is that we've got a period of pi for this particular function, or in really we have a period of 2 pi over 2, so hence a period of pi. So this function is going to repeat inside our distance of pi. So at pi, at 2 pi, and then at 3 pi. Now for all of these, this function is going to be symmetric kind of above and below the x-axis. And so what we actually find then is that the area in between 0 and pi over 2 is going to be equal to the area that we would have just between pi over 2 and pi. And so one way of evaluating this integral is to say, all right, how many of these areas are we going to have? Well, 1, 2, 3, 4, 5, 6 different areas. And so this integral will actually be equal to 6 times the integral from 0 to pi over 2 of root 2. And since sine is positive, sine of 2t is positive between 0 and pi over 2, we can drop the absolute value signs and say that this is just the sine of 2t dt. So now we're able to just go ahead and integrate that, and what we find then is that we have a negative 6 root 2 cosine of 2t over 2, and that evaluated between 0 and pi over 2. So if we just plug in our limits, what we then have is a negative 3 root 2. So we plug in cosine of pi over 2 times 2. That's going to give us a cosine of pi, minus what we get when we then plug in 0, so 2 times 0 gives us 0. So we actually have a negative 3 root 2 times a negative 1 minus 1, so a plus 6 times the square root of 2, or giving us an approximate value of 8.485281,374. So I hope you've enjoyed this video. I hope it's been instructive, and I will see you guys in the next example.